Hello everyone. Today I am going to start chapter solid state, and in today's video I am going to talk about types of solids. I'll be talking about isomorphism, polymorphisms and classification of crystalline solid. Let's start. Solids. Solids are the one which you can say it is one of the type of state of matter and used to be characterized by strong interparticle force of attraction. As a result, most of the solids have definite shape and volume, and which usually change only slightly with a change in temperature and pressure. The smallest constituent particle of various solids are atoms, ions, or molecules. And in this chapter, we are usually refer as particles to any one such particle like atom, ion, or molecule. Now, types of solid. There are two types of solids: crystalline solids and amorphous solid. Crystalline solids. Crystalline solids are those which are having regularity and periodicity in the arrangement of constituent particle, and the ordered arrangement of particle extends over a long range. Solids have sharp melting points. They used to melt at definite temperature. All crystalline substances except those have cubic structure are anisotropic, means the properties like refractive index, thermal and electrical conductivity are different in different directions. Example: ice, sodium chloride, metal like sodium, gold, copper, diamond, graphite, ceramics. These all are crystalline solids. Now, amorphous solids. Amorphous solids are those where the constituent particles are randomly arranged. The particles do not have long range ordered structure and they have short range order. Amorphous solids do not have sharp melting points. They melt gradually over the temperature interval. On one range of temperature, they usually melt. And on heating, amorphous solids gradually and continuously soften and start to flow. Solids which are amorphous are isotropic. That means properties like refractive index, conductivity, these all properties are very much independent of the direction of measurement. They exhibit the same magnitude of any of the property in every direction. Example of some amorphous solids are glass, plastic, rubber, tar are amorphous solids. And you can see here the particle arrangement of crystalline solids and amorphous solid. Crystalline solids are those particles are properly arranged, and in amorphous solid the particles are randomly arranged. Now, the difference between the crystalline and amorphous substances you are seeing on the screen. They have definite or you can say definite geometrical shape. The amorphous are irregular. Crystalline substances having sharp and characteristic temperature, or you can say they have sharp melting points. They used to melt over the long range of temperature, and like in crystalline they are anisotropic, amorphous they are isotropic. Crystalline are true solids. Amorphous could be called as pseudo solids or super cooled liquids. The particles got long range order in crystalline and the particles got short range order in case of amorphous solids. Now, another two terms, isomorphism and polymorphism. Isomorphism. Two or more substances having same crystal structure are said to be isomorphous. For example, sodium fluoride and magnesium oxide. They have same atomic ratio, means in sodium fluoride the atomic ratio in between sodium and fluorine is 1:1. Similarly, in case of magnesium oxide, ratio in between magnesium and oxygen particle is 1:1. So they are isomorphs. Similarly, if you are taking one more example, sodium nitrate and calcium carbonate, the three particles which are there in the sodium nitrate are sodium, nitrogen and oxygen, having ratio 1:1:3. Similarly, if you are seeing calcium carbonate, they are also having three particles having atomic ratio in between calcium, carbon and oxygen is 1:1:3. Polymorphism. Polymorphism, a single substance that exists in two or more forms or crystalline structures is said to be polymorphous. Polymorphs of a substance are formed under different conditions. For example, calcite and argonite are the two forms of calcium carbonate. Another example, alpha quartz, beta quartz and cristobalite are the three forms of silica. Polymorphism occurring in element is also called allotropy. And few examples which you must have heard is the allotropes of carbon is diamond, graphite and fullerene. Now, types of crystalline solids or classification of crystalline solids. Crystalline solids are further classified into four categories: ionic solids, covalent network solids, molecular solids and metallic solids. So let's talk about first ionic solids. In ionic solids, the constituent particles are charged ions. That means they are cations and anions. And when they are made up of differently charged ions, they must be experience electrostatic force of attraction between the oppositely charged ions. They are hard and brittle. Their melting point are quite high. And the specialty of ionic solid is they are poor electrical conductors in solid state, but when they are taken into the molten state or in a aqueous state, they are very good conductors. And the examples of ionic solid is like sodium chloride or calcium fluoride or potassium sulfate or potassium chloride. These all are the ionic crystals. Now, covalent network solids. Covalent network solids, the constituent particles are atoms, and the atoms in these crystals are linked by covalent bonds. The result of the rigid three-dimensional network of a covalent solid used to form a crystal having a giant molecule. The entire crystal is a single molecule, and as a result of rigid and strong bonded structure, covalent network crystals are very hard, and you can say they are the hardest and most incompressible of all the materials. They have very high boiling points, or you can say melting points. The electrons are localized in covalent bond and they are not at all mobile. Because the electrons are not mobile, so these are poor conductors of heat and electricity. Most famous example of covalent network solid is diamond, or another example is silica, boron nitride, carborundum are the covalent network solids. Now, molecular solids. Molecular solids, substance like chlorine, methane, hydrogen, carbon dioxide, oxygen. On solidification, they used to give you molecular solids. The constituent particles of molecular solids are molecules. And the bonds within the molecules are covalent. The molecules are held together with various intermolecular force of attraction. It could be London forces or London dispersion force. It could be dipole-dipole interaction. It could be hydrogen bond. They are soft and their melting points are also low. They are poor conductor of heat and electricity, and they the example of such solids are like dry ice, benzoic acid, or ice. Next is metallic solid. Metallic solids or metallic crystals. Metallic crystals are crystalline, and these crystalline solids formed by the atoms of same metallic element, and they usually held by metallic bond. In solid metal, the valence electrons are delocalized over the entire crystal, leaving behind the charged metal ion. Therefore, metallic crystals are often described as an array of positive ion immersed in the sea of mobile electrons. The attractive interaction between the cation and mobile electron constitute a metallic bond. You all know metals are malleable. They can be turned up into thin sheets. Metals are ductile. They can be drawn into wires. They are good electrical and thermal uh, conductors. Examples are like sodium, potassium, calcium, lithium, iron, gold, copper, etc. So, this is all about the types of crystalline solids.